Why very few are here? Okay, anyway, I cannot do anything. So in the last class, I was telling you about biometric standards and multimodal biometrics. So I told you about biometric standards. Standards are dime a dozen. There are international bodies, national bodies, companies and consortia, a group of companies, professional associations like IEEE, ACM, trade bodies like Civil Aviation Organization, OASIS, which are in the aerospace sector. They are also forming standards. So there are so many standards. But we have to understand that it is a jungle of standards. We cannot do anything. That is how it is. There will always be vested interests with respect to the industry. I told you, give you the example of Apple. Apple is a closed standard. Apple does not want interoperability, but to some extent interoperability is needed. So there are ways to get interoperability, but they want their platform to grow. Why would Apple help Android platform? Just because Google is promoting Android, Apple is not going to help in any way. So that kind of issues will be there for all biometric standards. There are many bodies and we have to live with that. And we have to hope that these diverse interests, some of them may be even vested interests, these diverse interests, just talk to each other and come to some degree of agreement with respect to the biometric standards. Then I also told you about the biometric, multimodal biometrics. Generally, multimodal means multiple biometrics. It can be, it mostly alludes to having two different types of biometrics. Even though we can say multimodal can include, different times you are taking your biometric, or different sensors, or different matching algorithms. You can use different algorithms to do the matching. But generally speaking, the multimodal biometrics allude to two different biometrics. Like the Aadhaar is there, we are using the fingerprint and the iris. There are two biometrics, and they are independently taken. And whether the decision involves taking both of them or not is another issue. But we are anyways having a decision with two biometrics. When you are taking the decision, is it after feature extraction or after the decision or after combining? That's a different thing. But ultimately, we are having two different biometrics. So that is the concept of multimodal. Multimodal are better because we will be able to minimize the FAR, false accept rate, and the FRR, the false reject rate, to the bare minimum. That is the idea. And that is what we want to use. When we have multimodal biometrics, we are able to minimize this FAR and FRR to the most less amount as much as possible. So today we will be learning a kind of an enabler, a logic, a template that makes biometrics work, which is mainly connected with image processing, as also machine learning and so on. Even machine learning, biometrics, video processing, all of these have pattern recognition as one of the foundation for these technologies like biometrics, machine learning to work. We need pattern matching and pattern recognition. Now, a pattern is an opposite of chaos. Pattern means there is an entity that is clearly defined. It is an entity, it is defined, it can be given a name, and it is having some clarity, some order. So it is the opposite of chaos. Opposite of chaos is order, and there is some clarity, some entity, some things. And generally we are taking an input, we are sensing something, and what we try to do is in pattern recognition is that we take an input, we sense different inputs, different records, different measurements, and finally try to make them, classify them into some sort of category or class. Now, this is the very foundation of data mining. The foundation of machine learning, data mining, the very foundation of biometrics. All of these focus on pattern recognition to be one of the bedrocks or the foundation of all these things. See, you are giving your fingerprint. The fingerprint is taken as an image. Fingerprint, the features are extracted and a pattern is stored in the database. Second time you give your fingerprint, again the fingerprint is sensed. The features are extracted and your features are matched with what is already there in the database. So essentially it is nothing but a pattern recognition problem. And pattern recognition is like the bedrock or the foundation for all these biometrics. So pattern is basically the opposite of chaos. There is an order. There is a symmetry associated with this. And now we come to how pattern recognition becomes the foundation of machine learning. Machine learning generally is divided into supervised and unsupervised, which I'm sure you know. Many of you are doing, have done, know about machine learning. It's the in thing. And supervised learning is generally classification. Unsupervised is clustering. So it's not a very accurate synonym, but simply speaking, the classification is is basically what is classification is. It is supervised learning, and unsupervised learning. The most common type of unsupervised learning is the clustering, and we will see what it means. Now, when you say classification, you have A's and B's. What are you doing? You know how an A looks like. You know how a B looks like, and what is the classifying that is happening? We are classifying all the A's and the B's. We know how an A looks like. We know how a B looks like. Despite the different types of fonts that we are using for A and B, we are able to classify because we know the general contours of A and B. But now you see this, both are ones. One is written in one font and one is written in a different font. So what the machine learning algorithm does is it clusters. It groups all the similar categories or the similar records together. Like all are ones, but the similar ones are, there are two fonts of ones. This kind of font is kept into one cluster. The other ones where there is it's a simple font are clustered into a separate So this is the general and all of this is basically nothing but all of these is nothing but pattern recognition. Here also there is a recognition of a pattern. Here also there is a recognition, albeit different methods. Classification is supervised learning, where you know the label, where you know the category, and you are trying to classify as per the category or the class or the label. All these are the same. Class, category, label, they are the same. On clustering, you don't know the label, you don't know the category, you don't know the class, but you get the data and the data is clustered in such a way that we get the label. So I already told you about all these things. Now I have told you already about intra-class variability. Today you are giving your biometric. Tomorrow you are giving your biometric. The same person is giving, that is an example of intra-class variability. And inter-class is different people giving. So it's very interesting when you see the kind of T that is available from different fonts. All of these are T, but this T doesn't look like a T, right? So you can see the wide variety of intra-class variability that is possible for a simple alphabet in the English language, namely T. Look at the different types of T's that are available, right? And inter-class is two different people, but see this, sometimes the inter-class similarity is so high. These are identical twins. They are so close to each other. They are different people, but they are so close to each other. And here you see intra-class, it is the same T, but see the wide difference between this T and this T, how different it is. So sometimes intra-class variability may be very high and inter-class similarity may be very high. or interclass variability may be very low. See, look at this O and D. See, it's very different to O, D, B8. From if you have short sight, it's very difficult to find out the difference also. They all look very similar to each other, but it is not the same. They are different characters, they are different classes. Now, to explain pattern recognition, there are some use cases and studies. There is a license plate and there is what is known as the cats and dogs. It's a very famous research that happened in one of these universities. Oxford University and IIIT had done this very famous, and this is a very popular example of machine learning. In fact, when we teach machine learning, supervised and unsupervised learning, which is classification and clustering, we use this example. So what is this? You have an image, set, you have a data set with so many images of dogs and cats. This is the cat data set, this is the dog data set. Now, mind you, you know how a cat looks and how a dog looks. You know the unique features of a cat and a dog. A dog will have different types of ears. A dog will have, a cat will have whiskers. A dog will always be having a protruding tongue. There are some distinctive features in every dog and distinctive features in a cat. A cat will have a whisker, a dog will not have a whisker. But having said that, there are so many breeds of dogs and cats. Interestingly, there can be cats which look like dogs. There can be dogs that look like almost like a cat. Because of the wide variety of different types of species that are available in dogs and cats. And that is the issue. Now here it's very easy. Supervised or classification. Supervised learning, machine learning or classification. You know, it's very simple, right? It's very, very simple. You are you have different dogs, different cats. You know how they look. You know how a cat looks like, how a dog looks like. But look at this cat. This cat, where my cursor is moving, it looks very different from a normal cat, right? So you know how a dog looks like, you know how a cat looks like. You do a classification, which is supervised learning, machine learning. But look at this. Now you have a more complicated set. The images of cats and dogs are completely mixed together. Now, there are dogs which look like cats. There are cats that look like dogs. Now it is a major challenge, and how you classify, you can't classify them. You do not have a manual. You don't know the features of a cat and dog. You need the machine to figure out who is a dog and who is a cat. And that is done by clustering the similar samples, the similar things, and the labels or the classes are known. Now you don't know who is dog, who is cat. The labels are not known, the category is not known, the class is not known. But from this image, you are trying to cluster the common ones so that you come to a cluster of cats, a cluster of dogs. Mind you, there may be errors because there, as I mentioned, there may be cats that look almost like a dog. So those type of outliers will definitely be there when you are clustering, right? And this is a very common, this is a very popular this example, this research done by IIIT and Oxford, 7,000 plus images of cats and dogs of 37 different breeds, 25 breeds of dogs and 12 breeds of cats. You did a testing and see how, see, this is a cat or a dog. It looks very, very different, difficult to find out if it's a cat. It's an Abyssinian, it's a cat. But it looks like it has a long ear like a dog. So this kind of issues are there. And what actually happens, this is where your term project comes. You have to choose one biometric, any one or two traits. Trait is a feature. One biometric or two biometrics. You can decide that. Either you can take a fingerprint and iris, or you can take an iris alone, you can take a retina, you can take a handwriting signature, get a big, what should I say, a big data set of hundreds and thousands of images. And then you do the image processing goals. You have the segmentation. This is the first, the image segmentation. You have a cat. You have an image with a background which you do not need. You only need the cat, the body, the contour of the body. The other things are not needed. So this segmentation of the image. In this case, you need only the dog's head. You don't need the other part of the person holding the dog and so on and so forth. This is the first image processing operation of segmentation. Extracting the feature. I already told you, you have an image, you are extracting the feature. In this case, either you're taking the head of the dog alone as the feature. You don't want the body of the dog. So these are the typical, when you are doing pattern recognition, the typical image processing operations, segmenting the image, extracting the important features of the image, and then classifying as per the performance. So this is a very popular pattern recognition example. There is another pattern recognition example. This is a very interesting one, research. It's a good project also. A license plate reading system. Now here, obviously, if you are watching television, spy thrillers, crime thrillers, obviously you need to know about, you need to get a license, you need to capture the license, you need to find out the criminals, you need to get access to the databases of the transport departments and so on. And there is always a challenge. There are the car is moving, it's a moving target, it's not stationary. The color of the license plate varies, the font in the license plate varies, the images, if any, varies, and every state will have its different this thing. In the US, I have seen some license plates are so different. They have a map. There are Republican Party supporters. They'll put a Republican Party flag in the license plate. They'll put a Trump supporter. I love Trump. MAGA, make America great again. MAGA, what is that? I think it's not allowed as per the law, but still there are people who make all kind of funny license plates with the name of their state, the name of the company, name of their political affiliation, different fonts, different lettering, moving target. It is a huge challenge. You have to acquire the image, enhance the image, segment the image, extract the image, recognize the image, and see the processing. Localizing the plate means getting the plate in a moving target, finding out if a car is moving, you got one frame of the car. You have to find out where that license plate is. It can vary from image to image, then doing a pre-processing, normalizing, cleaning it up, segmenting, feature extraction, character recognition. This is and see the challenges. This is what I was trying to tell you. Michigan State, the flag is there. Kentucky, there's an image of some cultural icon. And here, that's what I told, Trump supporters, MAGA, make America great again. You can put a MAGA poster here, along with the number. It's so complicated. You can imagine the complexity. At least in India, we don't have that much of an issue. The transport departments are generally more or less, they have some clarity with respect to you're having, but there are some people who don't follow though, but there are some this thing, and there are a lot of challenges. Image resolution, blur of the image, contrast, different fonts, background variation, all these are issues. So pattern recognition is used. Pattern recognition needs, there is another thing, classifying trees, classifying fruits, fruit sorter. So there are many use cases, classifying fish. So many use cases. There are fish that look like a snake. This is an eel. It looks like a snake, not like a fish. This is also a fish. I don't know what it is. I don't know. Starfish, whatever. It doesn't look like a fish at all. See the issues with respect to. These are all different type of use cases, but we need what is known as more of features and more of samples. So whenever the number of samples are high, it is better. More training samples, more images. When you have 7,000 images of dogs and cats, the classifier will have less error because more images are there. At the same time, if you have less number of samples and too many features, again the error is a problem. So always have more number of samples, more number of images, your home. And more number of samples, if you have more number of features, it's fine. But if you have less number of feature images or training samples, then more features you can get the curse of dimensionality. Less number of images, more features. It's a problem. So these are some issues that we find. There's also something called, what is this? Occam's razor. If you have two equally likely solutions to a problem, choose the simplest. A very simple thing, no rocket science. So these are the various use cases of all the kind of the use cases of the different kinds of pattern recognition systems, tree sorting, fish sorting, fruit sorting, and see how images. This is Richard Nixon, but this is also Richard Nixon, right? This is a cartoon of Richard Nixon. It doesn't look like him at all. This is, I think it's Winston Churchill, but this is also Winston Churchill in a cartoon. So all these issues of representation is there. Now today, pattern recognition has become the bedrock, the foundation of so many different technologies, including biometrics, machine learning, image processing, video processing, security applications. Pattern recognition is the foundation bedrock. Anywhere and everywhere we are using speech recognition, voice recognition system. You are giving the speech, and from there you are getting the identity of the person. Non-destructive testing. You're testing for some product that you have manufactured. You do a non-destructive testing. You do an ultrasound on it, an eddy current on it, and see how it reacts. The flaws will come out. You have pattern recognition in the ECG, EEG. ECG is electrocardiogram. EEG, that is the heart beat. EEG is electroencephalogram, if I'm not mistaken. That is the brain waves, the brain function and the brain chart. That is also a pattern recognition. Remote sensing, satellite images, recognition of patterns. You know where the lake is. You know where the mountain is. You know where the valley is, the terrain. Reconnaissance. You're moving in the helicopter, or you're moving in the flight, aerial reconnaissance, again pattern recognition. Scanned images, pattern recognition. Biological samples, there is pattern recognition. Industrial inspection, there is pattern recognition. Factory automation, 3D images, biometrics, web search, fingerprint, signatures, so many. So we come to this conclusion that this recognition is basically the bedrock, the foundation of the image processing, the biometrics, and the machine learning. And that brings me to the assignment that you are going to do. Just give me a sec. I will take a little more time and then I'll leave you. I'll tell you why. Ayush knows that. So coming to your term project, what you are supposed to do. Sorry, the code is wrong. It is 340. It's an old code I've written here. Now, as I mentioned, you form a group of 3 or 4 or 5. Some groups can have 5, some groups can have 4. You choose one biometric trait or 2, preferably 2 traits you take. Iris and fingerprint, or retina and signature. So you can choose in whatever way you want. You can choose one behavioral biometric and one physiological biometric. You can choose 2 physiological biometrics. At least one you should choose, one biometric or trait you should choose. Get lot of images from a data set, find out a data set. That is why I was telling you, somebody who has done image processing course will find it easy. So have a team with somebody who has done this image processing elective. Apply the pre-processing, get the images, store the images, look at the pre-processing, use software to do the pre-processing, analysis, implementation, presentation, and so on. And there are so many tools that are available. You can use Python 3 with the biometrics toolboxes, TensorFlow, Keras, SkyMage, Matplotlib, which is having visual representation, OpenCV, which is very popular. Pillow, NumPy, PyCharm, Visual Studio, GitHub. These are the tools that we can use to make this. Now, this is how you have to give. You have to define the trait, define the problem statement, plan what are the tools, and there will be a submission before the midterm. And after the midterm, towards the end of the course, you do a presentation, and based on that presentation, I will award you mark. Now, interestingly, the way things are going, after midterm, you may or may not have too many classes. I may finish the syllabus ahead of schedule. So start working for this project. This slide is also put on your this slide is also there on your Teams area as well as your AUMS. I have put it in Teams also, so that it's easy for you. You're moving around. Now, as a thing for the students, from tomorrow and next week, I'm cancelling all the classes for you. Tomorrow there is no class. There is no class next Wednesday and Thursday. Tuesday is a holiday, Thaipusam. So Wednesday, Thursday, there are no classes. I'm giving you a break, but that is between you and me. Don't go and tell others that sir has given a break and put me into problem. So a gentleman and a gentlewoman agreement between you and me. My style is different. So I am giving you a break. Don't advertise it everywhere that I have left you free, because I'll be marking attendance for all of you. And you can start focusing on this project, start discussions. All the classes, that are 3 classes tomorrow, Wednesday, next Thursday, you can use these times. Start working on the project, start working on the exams, because the week after that I'm planning to do some evaluation. Now I have completed the one part of the course, the first part of the course. That is, and the files that are pertinent to you are, there is a slide on biometric fundamentals, there is a slide on biometric standards, and there is a slide on pattern recognition, which I just covered today. Now for pattern recognition, the slide and the course material are the same, but for the other concepts, that is biometric fundamentals, multimodal biometrics, and standards, there are course material which PDF files. I have put it in such a way that it is spoon feeding. You can easily look into it. This is the first part of the course, that is over. Second part of the course, we will be individually looking at around 10 plus biometrics like fingerprint, face, keystroke, signature, and all. So that is the second part of the course. But since I am way ahead of schedule, I am giving you a break. Please do not make use of the time. Start working on the project. Now, if you need any image processing expertise or something, just buzz me. I will ask somebody who's an expert to give you a seminar, either a student or a faculty, and you can get back to me through Ayush. Now, other department students, at least in the AUMS, all the areas are there. Aerospace, I have touched base with the help of Ayush. I have touched base with them. All the video lectures they'll be using, and they will join the class after the Pongal holiday and the week after that. So have a nice safe weekend, have a nice holiday, stay safe, and wish you happy holidays. If you have any queries, I'll be happy to answer. So no more classes for this week and next week. Tomorrow no class, Wednesday no class, Thursday no class. Okay, so there is nothing. Anything? Nothing. Okay. Okay, let me take your attendance. I know today I have taken a little more than required because of this. So all the aerospace folks are not there. They are all traveling back to home, and they are anyways up to speed with respect to the video lectures. Starting with Divya M is here. CCE Divya M. CCE Divya M. Okay, she's there. Okay, good. Okay, now CSE folks. Jagruti Srinivas Manjunath Reddy. Cool. Varshita Mohan Chandra Padmaja. Varshita Mohan Chandra Padmaja. Cool. Sri Ramakrishna Gautam Krishna Saket